Here's another set of examples of problems involving permutation, or it could be a combination. So we will find it out in our examples later on. And before you continue watching this video, please make sure that you've accessed first the previous video, which is important or related to this topic, where we differentiated the use of permutation and combination. So I'll be flashing a card on the upper right corner for you to access that video. Now let's answer our first problem, which was also presented in the previous video as your assignment. A team of 17 softball players needs to choose 3 players to refill the water cooler. Find the number of possibilities, or how many ways can we select 3 players out of this 17 softball players. Again, in order for us to analyze whether it's a permutation or combination problem, try to select a specific result. Let's say, for example, I chose student A, B, C. Try to shuffle its order. And let's say I chose, what if I chose B, BAC? Now, based on the problem, does choosing player A, B, C different from players BAC? The answer is not. They are not different. They will be taken the same, since our goal is just to pick 3 players regardless of the order. So the order here does not matter. Logically speaking, because they will be just the same people, whether A comes first or B comes first, they will be the same group of people who will be refilling the water, right? And if the order does not matter, then this is a combination problem. And if it's combination, so we identify our N and also our R. So our N is 17. And combination of 17, we are taking 3 at a time. Putting it in our formula, so we have 17 factorial over 17 minus 3 factorial times 3 factorial. Let's expand. We'll have 17 factorial over 14 factorial times 3 factorial. Again, expand 17 times 16 times 15 up to 14 factorial. So we can eliminate the 14 factorial in our denominator. So cancel it. And we're left with 3 factorial. So let's rewrite it below. 17 times 16 times 15 over 3 times 2 times 1. And we can cancel the 3 here in 15. And 15 will be left with 5. And 2 can be cancelled from 16. And 16 will become 8. And now, to get our final answer, we'll have, or we will be left with 17 times 8 and then times 5. And that is 680. That is 680. And 680 will be our final answer. For our last problem, the student body of 10 students wants to elect a president, vice president, secretary, and treasurer. Find the number of possibilities. I'll give you 10 seconds to decide whether it is a permutation problem or combination problem. If your answer is permutation, then you are correct. Now, why is it a permutation problem? Let's take again a specific example. Since we're picking for president, vice president, secretary, and treasurer, let's say A was elected as president, B as VP, C as student C as the secretary and D as the treasurer. That will be different if B becomes the president, A becomes the VP, and D becomes the secretary and C becomes the treasurer. My point here is that in this case, order matters. So it's a big factor in order for us to decide whether it is a permutation or combination problem. And since order matters, then it is a permutation problem. Now let us solve. What is our N? What is our R? So here we have 10 students, so this becomes permutation of 10 students taken 4 at a time for the 4 positions. And in our formula, we'll have n factorial over n minus r factorial. And that will be equal to n factorial over 10 minus 4 factorial. And that's also equal to 10 factorial over 6 factorial. Now let's expand. 10 times 9 times 8 times 7 times 6 factorial over 6 factorial. So we can eliminate the 6 factorial. And we are left with 10 times 9 times 8 times 7. The final answer will be 5,040. So there will be 5,040 ways for us to select 4 students out of this 10 students if order matters. And for your task, here it is. There are 50 people at a meeting. They each shake hands with everyone else. How many handshakes were there? So how many possible handshakes can we make out of this scenario? Think carefully and don't forget to comment your answer in our comment section. Thank you for watching.